Good day, my fellow viewers. On this video, I'll be working on the application of Pythagoras Theorem, to real life situation. Don't forget to share this video across your friend. Subscribe if you have not subscribed before. By the end of this video, at least you will know how to handle some word problems on Pythagoras Theorem. And this series will take us to journey of depression and elevation. Don't forget to subscribe and share. Now, when we talk about Pythagoras Theorem, it's a theorem that is very common in mathematics. As a mathematician, a beginner, you are a real mathematician, you must understand the word in this name called Pythagoras Theorem. Now, Pythagoras is the name of a person, which is the name of the person that generated this theorem, how to work on the what, and a shape of this point. This is a vertical and what? Perpendicular, parallel. Now this is what? Now let us to know that this is this. Now this is going to be the height. This is going to be what? Distance between the what? The pole. We use the pole. Let me use the pole. Distance between pole and the slant. This is called slant height. Do you get me right? This is called slant height, and this is going to be distance between the what? The foot within the both field. Now, how do I apply it to real life situation? Just know that facing of this place, we call it what? Hypotenuse. Take note of that, and which I've explained that before now, which is under SOHCAHTOA, Now, supplementary ratio. Any angle given to you, if angle is given here, this is going to be the what? The opposites. And the last one will be the adjacent. Now, I'm not here to talk about that, but I'm here to talk about the application part of it, which is the word problem attached to all this Pythagoras theorem. And it's a very common, is what we use most every day in our daily life. Now, Pythagoras theorem state that hypotenuse squared equals to opposite squared plus what? Adjacent squared. Now, mind you, adjacent and opposite position does not matter. Don't forget that if I have A plus B, the same as B plus A, there won't be any problem because of commutative property. Now, I think by now I can say that slant height squared equals to what? Height squared plus what? D squared. Now, that is what is called Pythagoras theorem. This is going to be Pythagoras theorem. Now, on this video, I want to apply this to a real life situation. I will give out I have 1, 2, 3, 4, 5 questions there, and let's see how it will go before we continue on our the journey of depression and elevation. Permit me to rub it up. Okay. Don't forget, this is a vertical wall because I noticed that the light is affecting them. Now, look at this problem. There are two problems there. I think I still have more. I think time allows us to do everything. Now, the equal side of an isosceles triangle are 30 centimeters long, and the base is 24 centimeters. Calculate the vertical height of the triangle. This is a very nice question that somebody can ask anywhere. Let's see how it will go. Now, this is isosceles triangle. This is isosceles triangle. It lets us to know that this place is equal to this place, and the angle also is equal. This is called isosceles triangle. And the man said that what? Which is going to be 13 centimeters. Here will be 13 centimeters. Is equal. Now, and the base is what? 24 centimeters. You are now asked to calculate the vertical height. If I were you, I would call this place A, B, C. Now, for me to calculate the vertical height, this is the vertical height that I was talking about. This is the height we are talking about. Now, don't forget that this should be, what we are looking for. I can title this place O. It means now I will be having something like this. This is going to be O, B, C. 13 centimeter, H and what? And this from here to here is 24. it means we are now using half. Here will be 12 and here will be 12. It means 12 centimeter. Now from there you can now continue your journey by saying that hypotenuse squared, don't forget that hypotenuse equals to what? Opposite squared plus adjacent squared. Now at this junction we have 13 squared equals to what? 12 squared plus what? I squared. Now it means I'm having 169 minus 144 equals to what? I squared. Now at this junction, permit me to manage this thing, sorry, because of space. I'll be having h equals to, this one will be 25. It will be what? 25. Now 25 centimeter. Now this is going to be squared and I will root the both side. My h equals to what? 5 centimeter. It means the height is what? Is 5 centimeter. Now mind you that at this point you are to write out square root the both sides. Some teachers are, they are in need of those things. If possible, make sure you write it out. Now a ladder leaned against a wall, vertical wall, is what? 11.18 meter height up against the wall. The foot of the ladder is 5 meter from the what? From the wall. Calculate the length of the ladder. This is very simple. Now, solution to this problem. Now, I'm talking about ladder at this point. This is the wall, and we are told is what? 11.28 meter. Now, and this is the what? From the foot to the ladder. Now, this is going to be the ladder. Permit me to draw. This should be a ladder. We all know ladder. Okay. Now, and is 5 meter. Now, we are asked to calculate the height. Don't forget that it must obey 90, which is an what is it called? Right angle triangle. Now, this is what you are going to work on. It means the length of the ladder. This is going to be the length of the ladder squared equals to 1.28 squared plus 5 squared. Mind you that it's good to put bracket like this. It's very good. It's very good to avoid some error. Now when you square this number, it will have 27.2384. The number continues plus 25. Now I'll be having this plus that will give us what? 152.2384. Now when I square root this number, my L will be equals to, at this point I've squared the both sides, which is I'll be having 12.34 centimeter. Now it means the length of the ladder is what? 12.34 centimeter. Now can you see how it's being done? At this point we look for height. At this point we look for what? The length of the ladder, which is going to be slant height. Now can you see the difference between them? Let me gather more questions on this part. Okay, permit me to rub the board. Okay, let's see. Let's work on this question now. Okay, I think you can see the question very clear. Okay, permit me to hold it. Now I just want to work on these two problems, and there are two more before I leave this application. Now, solution to this problem. Now I'm just giving you different scenario. Let's try to solution. Now look at this one. A chord of a circle is 8 centimeter long. It is 6.3 centimeter from the center of the what? Of the circle. Calculate the radius of the circle to the nearest whole number. Now look at, this is a circle. Now this is a circle. Permit me, I may not draw it very well, please let me manage. Now what's a chord? A chord is a line that divides circle to two unequal parts. That is what you are going to understand. Now, this should be a chord. Now, anyone that is forming here, now, if I have a line here, and this happens to be a center, my hand, and I'm just sketching anyway. Now, any line that passes through here is called diameter. Please, can you see the difference between chord and diameter? Now, it's 18 centimeter, and we are told that it is 6.3 centimeter from the center. This is going to be from the center. That is 6.3 centimeter. Now, calculate its radius. Now, that is radius. Now, it means here is called radius. Now, from here to here is what? Is 18 centimeter. It means here will be 9 centimeter. Here will be what? 9 centimeter. Permit me to. Now, that is number angle 90. Now, at this junction, I will look for the one side of it. It means I'm saying that my hypotenuse squared, which is r squared, equals to 9 squared plus 6.3 squared. Now, 81 plus what? Now, when you have square root of it means 39.69. Now, my r would now be equals to square root of addition of the both. It will be 120.6. Now, it means my radius will be equals to what? Approximately 11 centimeter. Now, that is, it means my radius is what? 11 centimeter, approximately 11 centimeter. Now, can you see how circle can, be a problem? Now, look at a vertical stick is 8 meter height. This is going to be the stick, and the stick is this given to us like okay. It's going to be like the stick is 8 meter long, and length of the shadow is 6 meter. 6 meter. Now, find the distance between the what? The top. This is going to be the top. It's going to be top of the what? And the what? This is going to be what you are looking for. I think I can call it this one length. And this length, you know that is facing 90, is also known as what? Hypotenuse. It means my length squared equals to what? 8 squared plus 6 squared. Now, 64 plus what? 36, which is going to be 100. Root of 100, which is my length equals to what? 10 centimeter. No, sorry, it's 10 meter. 10 meter. 10 meter. Now, that is what you are to do there. Now, permit me to write two more. Permit me to write two more before going to depression and elevation. Okay. Look at this question. Let me quickly allow you to. Now, please quickly write the question so that we'll be able to see it. Write the question. You can pause a bit for you to see the question clearly, because I need to hone the light here for clear vision. Now, I have this particular problem. I think it's only this part that is being dirty. Okay, I have first question and second question, which is going to be the last set of questions for this application of Pythagoras Theorem. Now, the first one is talking about kites. Now, a kite flying at the height of what? 67.2 meter is attached to a spring. The end of the spring hooked to the ground is 47.1 meter from the foot of this kite. Calculate the length of the what? Calculate the length of the spring to the nearest whole number. Now, the first thing you need to do, you have to draw. This is going to be the height, 70 point what meter, and this is going to be the what? The distance we are talking about. Okay, meter, and this is going to be the distance now, which is going to be the length we are looking for. Now, mind you, note this. There are some questions that will come. This may be in centimeter, and the other one may be in what? meter. You do a bit of conversion. Okay, this is a very good example of conversion. I was looking at some question, and I was looking at, now this is one of them. Thank God I have one here that really explain that for us, because conversion is needed there. Now look at this. I will go for my Pythagoras theorem. We say that what my hypotenuse squared equals to 67.2 centimeter, squared, plus, which is 47.1 squared. Now I will now go for this equals to what? If I should square this number, I will have 5.84 plus 2218.41. Now, if I should add up, it means my L squared equals to, if I should add up the number, I will have 6732.25. Now, if I just square root the number, I will square root like this. I will square root like this. My L will be equals to 82.06 meter. Now, it means here is what? 82.06 meter. Now, that is very good. I'll be 0.1. Let me use 0.1 because of approximately 0.1 meter. Now, because of everything, they are in 1 decimal places. Now, look at this. This is very technical. Now, when you see a word due east, due north, due south, it's very simple to handle. Now, this is how cardinal point is being. This is the cardinal point problem. Now, here is due north, here is due east, and here is due south and due west. Now, west. This is 90. This is 90, which is 180. It means angle here to be 180. Here is 90 degrees. Now, this is another 90. Here will be 270. And here is 360. And 0 and 360 will be at the bottom. Now, it means from here to here is what? We call it northeast. Here is southeast. And here is southwest. And here is northwest. Now, I can generate another thing here, which is on the bearing. When I'm doing bearing, I will explain this very well. But here is 45, 45, and so on and so forth. Now, these are, bearing, these are direction anyway. Now, I have this problem, which is I need to solve this problem. Let's try to start with it. Now, a ship due what? North. This is going to be due north. Now, of a what? 4 hours at. Now, you are looking for distance. Is distance you need here? You don't need hours. Distance 1. And let's move on. Let me leave the time alone now. It will get to another point here, which is going to be another cardinal point. And it's also on what? Due east. This is going to be due east. Sorry. Due east. For another word, okay, I don't know how it is, which is going to be distance 2. Now, okay, how far is the ship from the starting point? This is another cardinal point. Now, it means how far. This is going to be the how far. Here is the how far. That is the distance, which is going to be distance 3. That is what you are looking for. Is on the question mark. But you have distance 1. Look at distance 1. My distance 1 will be equals to, you know that normally, for your information, we always say that our speed equals to distance all over time. Now, at this junction, this is going to be d1. It means my d1 will be equals to x multiplied by what? T. Now, what is my x there? My s is 28. Which is going to be 28 multiplied by 4. 28 multiplied by what? By 4. That is the first. Hope I'm not making any mistake, because I don't want to do this video. Now 28, which is going to be I will be having 112 kilometer. Now is in kilometer because this is going to be that as interpret, and mind you, kilometer per hour, meter per seconds, you have to understand those things. It means here is 112 kilometer. 112 kilometer, which means 112 kilometer. Now, distance 2, it means I'll be having distance 2 equals to what? Multiplied by what? T. Which is going to be what? I have is in 35 centimeter. I mean, 35 multiplied by 2.2. Now, 2.2, it will be it will be 77 kilometer. Now, this is going to be distance 2. Now, can you see my distance 2 is what? 77 kilometer. Now, I think I've solved the problem now. You know, the problem is half solved. The problem is what? Is half solved because of, let me just leave that for that. Now, the problem is half solved. I can now go by my Pythagoras theorem by saying that what? My distance 3 squared equals to what? Distance 2 squared plus distance 1 squared. Now, distance 3, I don't know it. Distance 3, I did not know it, which is equals to, what is my distance 2? I have 77 squared plus what? 1211 squared. Now, for me to have this, here will be 12455 plus 592. Now it means my distance 3 squared will be equals to addition of root of, which is going to be, I will square root the both sides. I will be having 8, 4. I don't want to be computing anything. That is why I have to write it out like this. Now it means my distance 3 will be equals to, when I square this number, I'll be having 0.92 kilometer. Now, which is approximately equals to 136 kilometer. That is the approximation. Now it means here will be what? 136 kilometer. Approximately equals to, it's not directly equals to anyway. That is all about that. You can see how simple this part is. Please master this thing very well, because if you don't know this, for you to get bearing and distance, depression and elevation will be very tough for you. Very, very hard. Trust me. Mind you, you can learn any mathematics on this channel. Thanks for watching.